Okay, let's get started. So this is a midterm review lecture, and most important announcement, obviously, is that the midterm is next class. It's only going to cover lectures 1 through 6, so just the SQL query stuff. I wasn't necessarily intending that. Then someone asked on Piazza, then one TA said just SQL, so I was like, oh, well, I don't know. I could either go back and tell them no, but actually it's like, we haven't really covered the data modeling, database design stuff probably well enough to be comfortable doing an exam questions on it. So yeah, lectures 1 through 6, all the homeworks, except for that part of the last homework that was on data modeling, I guess. Open book, open notes, but you can't share materials. Like if you have paper you want to that you printed out that you want to share, you can't do that, obviously. I'm going to assign seats because as you can see, this is like a very small classroom. Like we have 82 students in a classroom for 90 students. So you're going to have to sit next to someone, and you're not going to be sitting next to your friends, I guess. That's that. There's a 10-page practice exam posted, which I hope you find useful. And the answers are also posted. And also I posted last year's midterm. So I guess the practice exam is really long, so it'll give you lots of questions to work with. But then last year's midterm will kind of give you a sense of like how much like length to expect from the exam. I think that's useful. Yeah, question? No electronic stuff, devices, because that's a communication mechanism. Okay, so yeah. Which is a fair question, right? Because I have a lot of slides and stuff that you might want to use, and you might feel like printing them out is wasteful, but we don't really have a choice, like an alternative that would be workable. Yeah.
Is it similar format to like past year's midterms?
Yeah, it's like you'll have see a query, write what it's doing. Okay, I like those questions for SQL. So, yeah, if English is not your first language, then if you have like a English language dictionary, it might be helpful to bring that. I mean, I don't think it'll be necessary, but if I give you a diagram, a data model, if I give you a database that's on like Cricket or something, and you don't know what an over is, I don't know. I'm going to try not to confuse you. But it's possible that there might be some words in there that like I would assume everyone knows, but then you don't. Of course, you can always ask me during the exam, so that shouldn't be a problem. Also, there are some practice homeworks in Canvas that you can do if you get through all the practice exam questions. Yeah. Am I going to give out the partial credits? What do you mean? Oh yeah. So it will. Yes. So I will give you partial credit because the question I'm asking you to write a sentence, in English describing what the query does, and I think there's a lot of room for ambiguity, and so for two reasons. First of all, sometimes students write answers that don't like really make sense, and I'm not sure if they actually said the right answer. So in that case, like I might take off a few points. There are other cases when they clearly are giving the wrong answer, but it's not totally wrong. Like, okay, it's wrong, but it demonstrates at least partial understanding. So I'll give partial credit for that. Yeah. So otherwise it would be easy to lose a lot of points, I guess. Yeah. So I will give. Yeah. Question. It's exactly like the practice exams. Yeah. So look at last year's exam. I think last year I gave 9 questions that were just like, yeah, listing queries, and you describe what they do. Yeah.
I think you mentioned this on Piazza, but like, is it class curve, and is it always curved, and is always curved like up versus?
Yeah, the class. I always curve my classes because like otherwise it doesn't make sense. Like I'm not giving the same exam to all this. I don't know whether my exam is going to be like on target. There's no way for me to write an exam that I know will get like the right number of A's and the right number of B's in the class. So last year I had a situation where I curved down, and students hated me for that because it just so happened to like there were a ton of students that had like above 90% total, and I didn't want to give out like 75% A's in the class. It just like didn't seem right. So, but that's like I know like that it seems wrong. Like that's but like it's just that's just um, I think it's easy for me to justify it because again, there's no way for me to calibrate an exam so that it's gonna like be like so that it'll actually be the right level of difficulty so the numeric score comes out to be just right. It's a lot easier for me to just go through and like grade the exams consistently and like I decide to give half credit for a certain answer or not. Making those decisions on the fly is a lot easier than like making them, grading everything, seeing what the grades ended up being, then like going back and saying like, oh, like maybe I should have given less credit on this because actually the grades ended up being too high or too low than before, than like what they should be to like actually reflect the distribution of letter grades that I want to give. Yeah, potentially. I mean, look, this doesn't affect your studying, right? so why are you asking? I mean, so I don't think anyone. So I know that's annoying, and like maybe, but I think overall my grading is pretty fair, and the grades I give out have been like pretty generous. So I wouldn't worry about that if I were you. Yeah. Um. Yeah. So will you get partial credit? I think you could get partial credit if you just describe something that like is kind of mechanical and not really describing what happens. But in reality, the questions if you look at the sample questions, there are only a few that are difficult to explain, like what it's asking for. Also, incidentally, there's one question that uses recursive queries, like the extra credit one. We didn't cover that in this version of the class, so don't worry about that. The like with recursive student pairs, if you see recursive, like that's not something we covered, so don't worry about that. But did I answer your question? Yeah.
Something like question 5. That's probably
We're going to go through question 5 in class today. I think it's a good learning question, but that's way too difficult for. But look, on the other hand, though, let me take that back. I think that would be a good extra credit question because I would show you the query and I'd ask you what does it do. That's a lot easier than giving you making a request for you to build a query like that. Okay. Yeah. I would definitely do the practice exam. Yeah, it's different because the format is different. It's a reverse. You're writing the questions instead of writing the answers in some sense. So make sure you at least are comfortable with that format because it's very different. The reason it's different is because your homework you're doing in front of the computer, writing queries, you can kind of do it iteratively. There's no way to do that in an exam, and it's also difficult to grade. If I just ask you to write queries, you're going to make syntax errors, and then how do I grade that? It's like just kind of silly. So I like this format of questions. So just do the short. Like if you think you're doing well in the homeworks, then you could try just doing last year's midterm exam, 9 questions. So that's a short thing you can do. If that was all fine for you, except for the one at the. Yeah, if that seemed fine, then like maybe you don't need to do the full practice exam, just like 30 or 40 questions. Yeah. It probably will be the same databases. So you don't see this, but in last year's exam, I also gave a printout of the diagrams. Yeah. So don't worry about that. But you probably, you could bring them too, but I'll probably print them out just so that everyone definitely has them. Any other questions? Yep. I would go with whatever is shorter. I think that I phrase them as commands because it's shorter. It's like less words, fewer words. Anything else? All right, so that's, yeah. I have some slides here that go through everything we covered in class. And I think that I'm going to hold off on just like reading through these because I think that's a little bit boring. And you can do that on your own. Like these are all slides that I've shown before that talk about all the different topics in the class. But for your studying, I would look at this slide deck first, or maybe last, or both, to get an overview of everything we covered and make sure that you understand. By the time you're ready, the day before the exam, you should be able to go through these slides, the summary slides, and like understand everything that's written there. Okay, but I'm not going to talk through them now because that's kind of boring and it doesn't. What you really need to do is go through this, and when you see something you don't understand, then go to that lecture to get the details you're missing. Okay, I will mention that if you want to learn more SQL, like for an internship or a project you're doing later, there is a lot more to SQL than what we're covering, I guess. And this is a good book, SQL for Smarties. I guess it's an alternative to the SQL to the For Dummies book series that has like advanced SQL queries. So this kind of picks up where we left off, and so that's my recommendation there. Second half of the course, we're going to cover. We're going to talk a little bit more about data modeling and get some more practice with that. And then we're going to touch on a bunch of miscellaneous topics, like dealing with large databases is one. And then the other topics here are like different things you have to know to deal with, to create new databases, and to do data analysis in general. So different number formats, text formats, and like the way that different data files like CSV, XML, JSON work. So in other words, like to allow you to download data from somewhere and make use of it, and maybe like web scraping that's not listed and stuff like that. But I haven't totally settled the topics because that second half of the course is something that I've been a little bit more. I've changed every time a little bit more consistently. So I'm not sure what that's going to be. But what I want to do now is actually go back to the homework and talk about those difficult questions 4 and 5. Okay, so I think it was pretty clear from Piazza and from what I heard from office hours, in my office hours and from the TA's office hours, that people had trouble with those questions. So I want to like walk through them, I guess. Okay. So So let's start with, let me just bring up the questions just so we're all looking at the same thing. Just take a second. Assignments. Okay. So the two are related to each other, and the answer to the second question builds off the first one. So by the way, like, how many people thought that they got an answer to 4 that returned that number of rows? Okay, decent number. How about 5? Okay, like maybe very few. Okay, so no. Yeah, that's interesting because I thought that if you could get 4, you might be able to get 5, but 5 is more difficult. So I'll spend more time on 5. Okay, but we'll see how long this takes, and then if we have more time, we'll go through some more practice questions. So for question 4, it's asking to print the orders that could have been fulfilled by just one vendor. And one of the challenging things here was that you couldn't just like count the vendors available for the order. Hold on a second. Let me bring up my camera view. You couldn't just, for example, if you had an order, order 1 that had one product but it had multiple vendors available for that product. Wait. Could have been fulfilled. Actually, this is relevant for question 5, not 4. Sorry. Okay. So in order to answer this question, basically, you want to find the orders that can be filled by one vendor. So the way I approached this was to look at every order and figure out for all the different vendors how many of the products in that order can you fulfill. So it's like what I wanted to generate was a list showing the order, the vendor, and the number of products. Right, so if order 1 and vendor 2 has 3 products, order 1 with vendor 3 has 2 products, order 1 is only order 1 can be satisfied by one vendor if if there's some vendor who can supply the total number of products, right? So you want this to be equal to the total somehow, right? So that's a challenge there. But we can start off by generating this table. It's like, how do I know this is the right way to do it? Well, I don't know. I just sat around and thought about it for a while. That's not a satisfying answer, but that's the truth. Let me put this here. Okay, but does this table make sense? So for every order, how many products can be supplied by each vendor? And then once we have that in mind, then figuring that out is pretty easy, right? We select, we join the order details with, what is it, like vendor products? Is that right? Product vendors. And let's just print out the order number and the vendor ID. And I guess the product number. Okay, so this is a starting point. You see how it's printing out for a certain order. This particular product 1 is available from 2 different vendors, and product 6 is available from 2 different vendors. One of them is the same, but the other 2 are different, and so on. It might be more helpful if I reordered it like that. All right, so we have the orders, the products, and the vendors. But if I want to count the products for each order vendor combination, I can do a grouping. And the kind of tricky thing here is that I can group by order number and vendor ID. And I can, instead of printing out the product number, all those product numbers are going to be the same, are going to be different. But when I group them, I want to actually count the number of products available. So this is a relatively short query. It gives us, for each order, for all the different vendors kind of available for that order, how many products can they supply? Yeah, question?
So how does the group by 2 column works? Does that group by the first and then
Yeah, good question. When I have 2 columns in a group by, the meaning of that, the semantics of that is that both of them have to be the same. So it uses both of them. So kind of like, it's kind of like order number and vendor ID, or order number concatenated with vendor ID.
they have to be
Both of them have to be the same. So like, you'll notice if I look at these two first columns, that I'm printing out the same ones I'm grouping by, and they're different every time I go through. And the count here, like this 3, refers to the number of rows that had order number 1 and vendor number 6. Both those exact values. Okay. Okay.
The number of pairs of 1, 6, 1, 7, 9, 9. Just writing out each one individually.
So let me take a step back, like a rewind. First, I had this. So the green stuff is commented out. All right, that's what the dashes are. If first I had the actual product numbers, it's like for every order and vendor, I listed the products available from that order. And there are like 9,486 rows printed out. When I add the group by, it reduces it to like half that number, and it doesn't allow order number and vendor ID to repeat. Instead, it combines all the rows that have the same vendor ID. So those are going to be cases where you have the same order, same vendor, but many different products available, like from that vendor for that product. Yeah.
So then, well, in this case, which product number does it choose?
It's choosing a random one, which is why if I was grouping, I'd want to actually change it to do something more meaningful, which is like if I'm using a column that's different, just printing it straight up, that's kind of weird. So instead, I would want to probably print out the count to give me like the number of products. No, it doesn't matter. Because they both have to be the same. That's why it wouldn't matter. Yeah.
So like when we are using a group, I would only use the aggregator function, like this, or like to count something like when we are combining those rows, and we do something else.
When we group by, you can print out column names or formulas. The aggregators are most useful, right? Because if you have many rows you're combining, can you write your own aggregator? I believe you can. In SQLite, I believe you can actually write some C code. If you use the right format, you can write your own aggregators and load it into SQLite. I haven't done that, but I believe it's possible. Yeah. Say again. Yeah. I can change the. I think that if I change it down here, it would actually do it that way. Right, that's what it's doing here. But another way to do it is to just order it. So if you order by vendor ID first, and then order number. So again, without this, it's just chooses the first column to be the primary sort. But if I explicitly say that you want the second one to be the primary sort, so it'll put all the ones first, and then within that, it'll use the secondary order number to sort. Yeah. Are we all good on the meaning of this? Okay. This again, the question we're trying to answer is how many print the orders that could be fulfilled by just one vendor. And we started off by printing out for every order how many products can the various vendors supply. Now, not every vendor is listed. Some of them, like because it's not a left join, it's an inner join, it's leaving off. Like vendor 1 is not included for order 1 because vendor 1 is not actually supplying any of the products in order 1. But that's okay. But how do I know if order 1 can be supplied by one vendor? So how do I go from here closer to the answer? So I know how many products can be supplied by the various vendors. How do I know if a particular order can be serviced entirely by one vendor? Yeah, in the back. Yeah, if you need to kind of like this number here is close to the answer, right? It tells you how many products are available from the vendor. If we knew how many total products were in there, we could do a comparison. And that would tell us whether that particular vendor supplies all the products for that order. So how do we get? So we basically want to add another column here. If we're working step by step, that prints the total number of products in that order. This is where probably my solution probably diverges from yours, if you got it, because the way I chose to do that was by doing another join like directly in here, without doing any subqueries or anything like that. Any ideas how we can get that with another join? Yeah, toward the front. Yeah, but right now that would lose. The problem is then you'd lose these rows that have information for each vendor. Yeah. Yeah, you could do it that way. I suspect that's how most of the solutions from the students were. I'm going to do this in a slightly different way. I'm going to actually join with order details again. I'm going to give it another name, OD2, order details 2. And when I do that, or actually I can't natural join, but I'm just going to, basically what I want to do is for every order here, I want to combine that with the list of all orders, items in that order, and then aggregate that down to a count to get the total number of products in that order. So if I join with order details again, and I make basically using the order number, let's say I have to go through and add the first table name wherever I'm using order number because it's ambiguous now. That's not right. Yeah, count distinct what? Well, I think we have to give it a column name to say what's distinct, because otherwise it would probably do the whole product number. Okay. Let's give this a name. Okay, so we joined in another table, but we're not really using it yet. And because we have a lot more rows in the intermediate table, but when that's how the count before was giving a lot more number, a higher result. But adding in just counting the distinct product numbers gave us again the same number for products. If we can get the total number of products in the order by doing a different count. Whoops. Which is the okay. So this final column here, I'm going to call this products in order. So it's getting a little bit complicated, I guess. But
So can you explain why the third row gives like the same number for every order?
why the third, this one here or this one?
I mean, the third row in a query, like the code you just wrote.
This one here. Why does this, which in this fourth row, give the same number for every order number, which is what I wanted, right? But why does it do that? Because it's counting up the distinct. So OD2 is the second copy of the order details table, and I'm joining it in based on this one here. The order number being equal to the this order number, basically. So for every one of these rows you see here, I'm joining in the order details table and including everything in there. So every product from that order is included. And if we count up the different product numbers in that grouping, like that'll include all the products in the order. Whereas this first one, I think maybe a related question is, why does this first one, this other count, return only a smaller number in the count instead of all the orders? That's because this is counting from the, okay, we have two different tables, copies of the same table being joined. So maybe drawing a picture might help here. Let's see. So for order 1, we have different vendors available, and then from the order, what did we do here? Counting the order. For each one of these vendors, we have many different products available. So for example, the first vendor might have these 3. The second one might have a different number, different products available. It could have a different number too, like 4 instead of 2. And the first join here counts the distinct product numbers within this grouping. So within this grouping, from this table, the number of products are going to be the number of products available from that vendor. But then the second copy of the table, OD2, this was joined with directly with the order table here. And actually, this was creating a full list of 7 products, because this is joining the order number with the product table to get all the products in that order. So here, it's after, but each one of these will have the same value for order anyway. And If we're in the first one, we're counting the distinct product numbers, which here it's going to be just the products that are from that vendor. But from the first table just shows the products from that vendor in that order. But then the second table shows all the products for every combination of order, vendor, and line item of product.
So is that because we're grouping by the rows in the first table rather than grouping by the rows of the second table? We're doing the group by. Because the group by is you choose
Yeah.
everything by group by, right? Because we're grouping by. Is this the difference why those two are?
Well, the group by determines that the first two rows are the ones that are different in the output. For each one of these, there are many. Actually, like when this aggregation here is combining more than one row to produce one. It's producing they're actually 1 times 7. There are 7 rows here, 14 rows here, 14 rows here, 21 rows here, 7 here, 42 rows here. But within that set of rows, so actually we have like, in this particular example, the intermediate table would look something like 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 3, all the way up to 7, right? Just for that one product. And the next one would be like this one is saying that product 2 is also available from the same vendor. So it'd be like 1, 1, 1, 2, 1, 1, 1, 1, 2, 2, all the way to 7. So if you count the distinct, because we're counting distinct products from this table, there are fewer than in this table. Like this table always has all the products. That's the difference. Yeah. So, but at this point, we can do a comparison of the numbers in these two rows to figure out which vendors are actually can supply all the products in an order, right? And to do that, you can use halving, because halving is filtering that works after aggregation, after grouping. So we want products from vendor to be equal products in order. So in this case now, we have fewer rows. And this is just showing, like, for all the different orders, if they can be entirely supplied by one vendor, who's the vendor? And there's some cases where the same order can be entirely supplied by 2 different vendors. So we don't. If the question is asking for all the orders that have this quality, we're not quite there yet. We have to instead print out. So I'm going to take a copy of this query, and I'm going to remove all this stuff up here, or let's just say I want to print out the distinct order numbers and I don't need to print out this other stuff, but since I was using the aliases down below, I have to like kind of paste them in here. Like so. So that's your 397. Sound good?
So having the where comes before group by and the having comes after.
Yes. Yes. And of course, this condition is using an aggregator, so it definitely has to be in having rather than where. It wouldn't make sense in where. Okay. So we agree that this gives the orders that can be supplied by one vendor. Now, question 5 is more complicated. It's asking for the orders that can be fulfilled by exactly 2 vendors. Okay. So I'd like to think about this for a second. So part of the trick to this is casting the question as an inverse or a complement question. So the question was we want to know the orders that must be fulfilled by 2 vendors. I mean, you can think about this for a while, but it turns out this is just difficult to tackle in SQL by itself, like directly. So the way I solved this problem was to say that this is the same as saying as if we can figure out the orders that can be fulfilled by 1 vendor and those that can be fulfilled by 3 or more vendors, and subtract those from the whole set of vendors. I mean, not vendors, orders. We take the orders that we take all the orders, subtract those that can be. So take all the orders, start with all orders, and subtract the orders that can be fulfilled by 1 vendor, and also subtract the orders that can be fulfilled by 3 or more vendors. We have the same answer, right? These are equivalent statements, right? The second one is more complicated, but it's easier to write SQL for. Right? In English, the first one is easier to state, but in SQL, the second one is easier to state. All right. So, do we believe this is true? If an order must be fulfilled by 2 vendors, then okay, clearly it's in the set of all orders, and it's definitely not an order that can be fulfilled by 1, because if it can be fulfilled by 1, then it's not true that it must be fulfilled by 2, right? Because this would contradict it. And the only other set of orders that is not included is the orders that can be fulfilled by 3 or more. So, right, because the ones remaining are those that either can be fulfilled by 1 or those that can be fulfilled by either the ones that must be fulfilled by 1 or those that must be fulfilled by 2. Okay. So does that make sense? It's kind of equivalent to some of the questions in probability are also easier to solve by complement. Like if you want to know the probability that you flip a coin 10 times and you never get a head, you never have the head show up, it's easier to calculate the probability that tails happens every time. Probability that flip a coin n times and never get tails equals 1 minus the probability that you flip a coin n times and always get heads. So it's like 1 minus 1/2 to the nth power, something like that. So we're doing the same thing in SQL. We're taking a question. So if you don't know much about probability, don't worry about it. But if you've taken a probability class and done that, then this will seem familiar. So you're taking a question and rephrasing it as a complement, and that helps to solve the problem. All right. So you should recognize that this first part here is question 4, right? And this one here, we don't know. So we have to figure out the answer to that second part. And then we can put these together by doing a query that gets all the orders. That's easy enough. And then we can use except to do a subtraction twice. Okay? So except is subtraction. Make sense? So to solve this problem, we have to focus on answering this question here, finding the orders that can be fulfilled by 3 or more vendors. Now, how do you solve that problem? You want to find orders that can be fulfilled by 3 or more vendors. I mean, does that sound easier than finding the orders that must be fulfilled by 2 vendors? Maybe not. It is, though. Because like must, the problem with must is that it means you not only have to find something is true, but find that something else is not true, is never true. Right? But to find an order, if an order can be fulfilled by 3 vendors, all it means is that, I'll write this down. There are 3 products in the order available from 3 different vendors. Right? Yeah.
I think there's actually a case where in the question it says exactly 2 vendors.
Yeah.
So it must be fulfilled by 2 vendors.
Yeah.
And doing that does not account for the potential that you could buy one set of products from one vendor
Mm-hmm.
and then buy another set of products from another vendor that are mutually exclusive.
No, it does. It does take into account, because if that was true, then those 2 sets are from the same order, right? Those are 2. You divide the order in 2, right? When you do that, then if you're simply looking for 3 products in the order available from 3 different vendors, those 3 products can come from either of the 2 divisions. So the key thing here is that we're not solving the original question. We're solving the subproblem because it's easier. So yeah. So but you still think that finding the orders that can be fulfilled by more than 3 vendors. So are you concerned about the step from here to here, which I think is a little bit of a jump, or the step from here to here?
I'm concerned about the last step.
Okay, going from here to here, saying that finding the orders that can be fulfilled by more than 3 or more vendors. I claim that that's just the same as finding orders where there are 3 products and those are available from 3 different vendors.
I can give you an example.
Okay, go ahead.
Just to give an example.
Yep.
3 products in order 1, 2, 3.
So the 3 products are 1, 2, and 3.
Right.
Okay.
Then you have 3 suppliers, A, B, and C.
Okay, yeah.
A can supply product 1.
Okay.
B can supply product 2 or 3.
Okay.
And C can supply product 3.
Okay.
So this does not meet the criteria that we were shown. And product 1 could be supplied by A.
Okay.
Product 2 could be supplied by B. Product 3 could be supplied by C.
So I claim that this can be supplied by 3 vendors by saying that A provides 1, B supplies 2, and C supplies 3. It can be supplied by 3 vendors. Therefore, because I'm subtracting all those from the full set, so also it is not one that must be supplied by 2. So it's not a counterexample. Nice try, though.
Is it possible that like product 1 can be supplied by
Okay. So in this case, this one must be supplied by 2 vendors, right? We agree with that? And consequently, it is not possible to find 3 products in this order available from 3 different vendors, right? 3 different products. I should say more precisely, right? Because 3 products from 3 vendors would have to be 1, 1, and 2, or 1, 1, and 3. But those are the same products, right? There's not 3 different products from 3 vendors. Okay, so I think that does maybe highlight the fact that I should say that the rule to find the set of orders that can be fulfilled by more than 3 vendors, we have to look for products that have 3 different products available from 3 different vendors. But they're not different products. They're not 3 different products available from 3 different vendors. Yeah. So you can't. You're saying. I'm saying that it has to be like you have to make a list of 6 things, right? You have to say a product, and a vendor, and a product, and a vendor, and a product, and a vendor, right? And the products all have to be different, and the vendors all have to be different, and they have to be available from each other. Okay? Yeah.
I'll try not to get too bogged down in example, but
There isn't one, trust me, but you can try to find one.
is it possible, like, I'm getting confused as to whether or not orders that can be fulfilled by greater than or equal to 3 vendors is like a subset of the orders that can be fulfilled by 1 vendor?
It's possible that I'm not making any argument that these 2 are mutually exclusive.
Right, but so then would you be like sort of double subtracting orders?
You can double subtract without it being a problem. So it'll do this subtraction first, and if you like the way that set subtraction works is that like okay, you might have like if you have 3, 4, and 7, and you subtract like 10 and 4, that's okay. The answer is 3 and 7. Okay, so if you like, so this is a case where like maybe we already subtracted the 10 before and we were left with this. We try to subtract it again. That's okay.
Right, no, I was thinking sort of you can't double subtract.
Okay. All right. So this here is a pretty simple, not simple, but it's a simpler problem to attack. Yes.
I said a question
Uh-huh.
on set, but
Yep.
I guess I can ask.
Well, yeah, what is it? Go ahead.
So, you need to do anything special with parentheses to kind of make sure that like you're subtracting rows from like the first table as opposed to like, the second table, and subtracting those rows from the first table.
I don't think it because of the way subtraction works here. It's a set subtraction or set exception. I don't know what the right term is for it in set theory. But if if we're just removing items from sets, if we start off with a set and then remove certain items, then we remove more items. It doesn't matter like what order we do that in. If you see what I mean. It's also true in like subtraction with numbers that the order doesn't matter for the second ones. Was that your question? Okay, maybe let's come back to it after because we'll show the code to actually do this. Okay. So if you want to find whether there are 3 different products available from 3 different vendors in a order, right? So how would you approach that? It's because I argue that it's easy or easier, but it's not really easy. It's just doable. It's easier than the alternative, which I have no idea how I'll solve this directly if it's at all possible. I'm going to find 3 different products that are from the same order and have different product IDs and different vendor IDs, basically. Right. So basically, to solve this problem, we can actually just try every combination of 3 products in the orders and see whether we can make this true, if you see what I mean. So this was question 4.
So these every 3 combinations of products.
Yeah. So it's going to be a large number, but we're going to filter it down to just those that meet certain criteria. And the database management system, because there's some filters, it won't have to actually build the full double Cartesian product. All right. So if we work with the order details table, right, looks like this. We know certain products are in that order. But so I want to look at not just one product, but 3 products in that same order. Now, the key step here is that in the in this wording, I know that it's exactly 3. So even though up here I have the statement is orders that I want to find the orders that can be fulfilled by greater or equal to 3 vendors. That is equivalent to finding the orders that have 3 different products and 3 vendors, exactly 3. If there are exactly 3 products from 3 different vendors in an order, that means that there are 3 or more vendors that can be involved in that order. It could be 5 or 7 orders, but as long as if I care only about the greater than or equal to 3, I just have to find 3. Okay. So let's try to find 3 products from an order that are available from 3 different vendors, 3 different products. Okay. I have 1 product here, right? I'm going to actually just join this in 3 times, or 2 more times to have 3 different combinations of 3 different product numbers for each order. All right, so how do I do that? I join it up. Let's say I'll call the first one OD1, second one's OD2. The third one is going to be OD3. And in this case, all I want is I want the same. I only want the products in that same order. So I'm going to join based on the order number. So OD1.order number equals OD2.order number. And then similarly, the third table has to have the same order number too. So it doesn't really matter if I do OD1 or 2 here. Okay, so I run it takes a while. It returns 150,000 rows. So let me just reduce the columns being printed so we can see it. I'm going to print order number, OD1 product number, OD2 product number, and OD3 product number. Remember, these are just different copies of the these are different copies of the order table, order details table. Okay, so for this order, I have product. I combine product 1. Basically, I have every combination of the 3 different products in that order. Right, the different products are 1, 6, 11, 16, 21, 26, 40. There's 7. And for each one of them, I try combining it with another, and for each one of those, I combine it with another. So you repeat the 7 over here, and then you go on and you try the next one, and so on and so forth, right? Gives all possible values for all possible 3 products in order number 1 are represented here. And if I scroll down a little bit further, eventually I'll get to a different order number 3, right? And there are a ton of rows here because I'm doing 2 Cartesian products.
So you should use like larger than in the join all, right? So you wouldn't have to otherwise
Yeah, so it's true that this this is repeating combinations we've already seen, but I don't think it necessarily matters because we're just looking for the existence. It might be more efficient to introduce some inequalities here to filter it, but in the interest of keeping the query shorter, let's not worry about that for now. Okay. So But right now, some of these products are the same actually. Right, like we don't want columns to. Well, okay, actually now I can introduce what you said. Like this row here doesn't help us to solve the question. It doesn't help us to find 3 different products available from 3 different vendors, because these are the same. Those are the same product, right? So I want to actually require that the product numbers are different. So maybe product number 1 has to be less than OD2's product number, and then also like all 3 of them have to be different. So you have to actually put in 3 inequalities. Maybe we don't need all of these, because if we're this one here is redundant, right? Okay, so product number 1, the first column's product number has to be less than the second column's product number, and the second one has to be less than the third one. And if we're going to choose a combination of 3, the combination we're going to choose is the one that puts the lowest one in the first column, then the middle one, then the last one. Okay. So now the number of rows went from 150,000 to 14,000. And importantly, we're only listing orders that have 3 different products, actually. So there's some orders, like as I scroll through here, you notice it goes from like, well, it might skip an order. It didn't in this case. So 5 does have 3 orders. If there's any orders that have fewer than 3 products, it will skip them. Like here. There's order number 9 and 10 are not shown because there's no way to print out 3 different product numbers for that order that have different order numbers, because there only is 1 or 2 product in that order. Okay. Yeah, so that's part of it. That's getting close to the solution, but so far I've only found the orders that have 3 different products. I haven't shown that they're available from 3 different vendors. But I can expand this to do that, right? And actually, now that I think about this, I have to undo what I did, because I don't know which vendors are going to be available for what product. So I'm gonna actually go back and make these equalities. And so now I'm printing. There's some cases. Sorry, I should say not equal. Okay, so I print 1, 6, 11, but I also print 6, 11, 1. Let's just leave that for now. We'll see why later. Okay. Because what I want to do is find a vendor for each one of these products and make sure those vendors are unique. Right. So basically I can join this up with 3 different copies of the vendor table, matching like this second column product number to one of the vendor table copies, and then the next one to the other copy, and so on. Okay, so if I'm adding in more tables, I have to go back to that join and add to it. Vendor products. Product vendors. So this is the first one. I'm going to call it PV1. And this one I'm going to require the first product number to match. And I'm just going to copy paste this for the 2 other ones and make it so the second and a third copy of the same table, and it's matching the second and third copy of the order details table respectively. Okay. And when I do that, I get 1 million rows, because I'm basically for every, I'm not doing any restriction on like, I'm looking at every possible combination of finding each of the 3 products from the different vendors that are available. Right. But basically what I can do here, though, is search for cases where the I guess I should make this a little bigger so we can see the whole thing. So just to make it clear what I did here, let me also print out the vendor names, vendor numbers. Okay, so what you see in the bottom is that for this combination of 3 products, 1, 6, and 11, you could get product 1 from vendor 4, and then at the same time get product 6 from vendor 2, and product 11 from vendor 3, or you could, have the same vendors for the first 2, but change the vendor for the third one. See that? So these are like all possible fulfillments for 3 orders from products that have 3 different products. And now we have the information to get to the final answer, which is basically just we have to look at these numbers to make sure they're different, right? We want the vendor IDs to be different for these 3 different products, right? Remember, this is saying where this product comes from. This is saying where this product comes from. This is saying where this product comes from. Which vendor? We want to make sure those vendors are different. We already know the products are different. So we just add down here to the filtering. Same idea as what we have already, but the first vendor can't be the same as the second vendor. And the first vendor can't be the same as the third vendor. And the second vendor can't be the same as the third vendor. Okay. And this prints out 570,000 rows. But for each one of these, there's a different combination of vendors used for a different combination of 3 products, actually. So these are all instances where, let me make this a little bigger to get the whole. These are all instances where you have you have an example that proves. These are all cases that prove this case here. There are 3 different products available from 3 different vendors for 1 order. Okay. So if we just select the distinct order numbers, we got to be unambiguous. We got 705 different orders that can be fulfilled by 3 or more vendors. With 3 different products that can be fulfilled by 3 or more different vendors, and you can combine them to get the answer to the question as follows. So, if you start off with all the orders, right, and then use except to subtract. This is the answer to Q4 that we did earlier. And then finally, down here, I'm subtracting the answer we just got. The only difference is I put in some comments describing what's happening. So we're removing all the orders that have 3 different products available from 3 vendors. We do that by listing all the possible combinations of 3 line items from each order with vendors. Make sure the vendors are different, make sure the products are different. And I don't know if we really need this group by at all, actually. I think that might be superfluous. Run it and get, that group by was not necessary. So we get 36 results in 2 seconds. So it takes a little while to run because of all the, especially the second query joins all these different tables and all the possible combinations. But yeah, this is the answer to that question. That makes sense? So let me go back to, this was, this is the answer to the just that this part, the second subtraction here, this is how you do it, right? You look for 3 different products in an order available from 3 different vendors. If that's true, then we know that this order can be fulfilled by 3 or more vendors. It doesn't have to be, but it can be. And we know that if it can be, then that means that it should not be part of the list that must be fulfilled by 2, because this one, it can be fulfilled by 3, so it doesn't have to be fulfilled by 2. Similarly, this first thing we're subtracting, those are the orders that can be fulfilled by just 1 vendor. We know that if it can be fulfilled by 1, it's not one of those that must be fulfilled by 2. All right. So that was fun, wasn't it? Yeah. Question? This one? The all one. Yeah, I can. It's too big to fit on one screen, but I can put this. I guess here you see how we start with all the orders, and then there's an accept, which has the query from question 4, and then accept that has that final one we just built. I'll put this on a slide. I'll put this and the Q4 answer on a slide. Sound good? So this was a good question because of course it required some SQL knowledge, like how do you do these joins when like you have multiple copies of the same table. That's pretty confusing, right? But more importantly, it helps you to like take a question that seems pretty simple and break it down into things that you actually can query and put those together to get the answer, right? And if anyone thinks that they have an idea for solving this without doing 3 different queries, I'd be interested to hear it. But now that we know the answer, right, there are 36 rows, you could test yourself, right? I don't think it's possible though, so I wouldn't like put a lot of time into it. All right, any questions? Any questions about the exam in general? I think also, I don't know. I think maybe we spent a lot of time going through, like we went through an advanced query today, which is good, but I think some people might benefit from seeing explanations of simpler queries as well. We don't have there's only 4 minutes left now, so I guess I'm not gonna be able to do that now. But I guess it's just a critique of my my presentation here. Note to self. But come to office hours certainly if you want to talk about that stuff. I guess the thing about this was that this was something the TAs weren't going to be able to explain to you because it was too complicated and they didn't have a solution. But for the simpler stuff, the TAs definitely can help you to work through that, and I can help you in office hours too. Okay. So see you all on Thursday.